Welcome to this Electrical Engineering Knowledge Sharing Channel, AMP Power System, presented by Anand Paul. We are discussing the various aspects of electrical engineering in this channel. We have already discussed 7 workshops, and under the 7 workshops, we have about 61 videos we have already completed. Now, today we are going to start a new workshop, that is workshop 8. In this workshop, we are going to discuss about the switchgear control schematics and its various aspects or features. In order to discuss the switchgear control schematics, we need to understand first how the switchgear's layout is made, or otherwise how the switchgear's various power components are arranged, and what are the various type of switch gears, what is the busbar arrangements. If these features we discuss first, then it will be easier for us to understand the control schematics, because all these arrangement components or the power components in these arrangements have some interlock with the control schematics. So before going into discuss the control schematics, we need to discuss first the switch gears. What are the type of switch gears available, what are the various busbar arrangements, and how the feeders and these various power components are arranged. We discuss this first, and once we complete this discussion, then we will go into the discussion on the control schematics and these various parts. Now, when we are going to discuss about the switchgear control schematics, these switchgears we will be discussing mainly medium voltage switchgears and the high voltage switchgears. We know that medium voltage switchgears are classified up to 33 kV, starting from 3.3 kV, 6.6 kV, 11 kV, or sometimes 13.8 kV, 22 kV, and 33 kV. If the switchgear voltage is above 33 kV, then we put into the high voltage switchgear or extra high voltage switchgear up to 800 kV. So we will be discussing first the various layout for the medium voltage switchgear up to 33 kV, and then onward we will go up to the 800 kV. The difference of these various voltage level switchgears are mainly their arrangement, various power components requirements, and how the components are connected to each other, that we will discuss in details. And that is one way to classify the switch gears. There is another way to discuss the switch gears about the installation location. Whether the switch gears are installed inside a building, means it is indoor installation or outdoor installation. Generally nowadays up to 800 kV switch gear we can install indoor with a special arrangement, and that is mainly used if the ambient condition or the location where the switchgear are to be installed, if that location is highly polluted, air is highly polluted, is a highly congested industrial area, high level of pollution, in that case install the switchgear outdoor is not very convenient. So we go for the indoor installation. But if the atmosphere is clean, it is not a highly congested industrial area, in that case we can go for the outdoor type of switchgear. But normally up to 33 kV we generally install the switchgear indoor. Above 33 kV onward up to 800 kV we go for the switchgear installation outdoor. Now indoor switchgear, there are various, this is from the locational point of view, switchgear can be classified in this way. Again, the switchgear can be classified whether the switchgear is indoors, is a fixed type, or it is a dropout type. Now when you go for the switchgear indoor, generally indoor switchgear can be two types. One is a drop type switchgear, another is a fixed type switchgear. Now drop type switchgear is limited up to the 11 kV or maximum 22 kV, not more than that. If the switchgear is more than 22 kV, then drop type arrangement we cannot make, because there is a other problem comes in. In that case, the switchgear must be fixed type. Now, when you go to the fixed type switchgear, that is mainly SF6 switchgear or the sulfur hexafluoride switchgear. But below the 33 kV on downward, 22 kV and downward, most of the switchgears, it is a drop type. It could be air circuit breakers, it could be vacuum circuit breakers, or it could be SF6 circuit breakers. We'll discuss all these switchgear arrangement one after another. So this is another way of distinguish the switchgears. And then another type of classification of the switchgear based on the busbar arrangements. Switchgear again classified as a single busbar switchgear, or double busbar switchgear, or three busbar switchgears. But our discussion will be trying to limit the switchgears within the single busbar or double busbar arrangement. Why we are discussing the switchgear in this way? Because all these arrangement has impact on the control schematics. When we will be going to the control schematics, we can see this has a high impact on the control schematics. Depending on the each type of arrangement, control schematics or the interlock circuits may be different. That's why we need to have some understanding about how the switchgears are arranged. So let us discuss one by one. So in case of indoor switchgear, this indoor switchgear can be two types. I have said one is a drop type switchgear, another is a fixed type switchgear. Indoor switchgear generally we can go up to 800 kV, but most of the installation it is up to 33 kV we make for the indoor switchgear. But above 11 kV indoor switchgear is a fixed type. Now drop type switchgear, why it is called drop type? Now when you look into the switchgear, this medium voltage or high voltage switchgear has a two part. One part is a power part, another part is a control part. Now the power part is coming how the generators or the power generating company or utility is giving power supply to a particular switchgear. That is the incoming power coming to the switchgear. Switchgear has a busbar arrangement which is receiving this power, and after receiving the power through the busbar, the switchgear is again distributing the power to the various outgoing loads. This is the way switchgear works. Now this busbar arrangement, if we look into the busbar arrangement, this busbar arrangement, as I said, there could be a different type of busbar arrangement. It could be a single busbar arrangement, single busbar in the switchgear, single busbar. It could be dual busbar, means two busbar arrangement, two busbar arrangement. It can be sometimes two busbar with a complementary third busbar, but we will be limiting our discussion within this two busbar arrangement. In the single busbar arrangement, how is this is the only one busbar system is there. We are drawing this for the single line purpose. We are drawing this, but actually this busbar is consisting of three buses. One is a red phase, another is a yellow phase, another is a blue phase. These are the three phases. Sometimes we say it as per IC, U, V, W. This is also another way of nomenclating the busbar system. This three busbar system, three busbar together we are representing by single one busbar. This busbar actually three busbar, red, yellow, blue. So this is a single busbar. What does it mean? In this single busbar switchgear, if you see the switchgear, there will be one line, one busbar. But this is actually there are three busbar like this. But there is only one. There is no section. This is the main busbar. It is a copper bus, or it could be aluminum bus, or it could be tin copper. So from this busbar, what we do, we take the feeder outgoing. We put the connected. How we do now? If we go on the single line, this can be represented by single line. If we draw a single line, this is the single line. From there, what do we do? In case of draw type switchgear, we put the symbol like this. This is a draw symbol. This symbol we call is a draw. When the symbol is present, this symbol means this power component is a draw type. I am discussing what is draw type, and this component we call it circuit breaker. This circuit breaker can be a circuit breaker, it could be vacuum circuit breaker, it could be SF6 circuit breaker. But when we put this symbol, means this circuit breaker is a draw type. We can put in, put out by mechanical device. Now this draw circuit breaker, why we need, that is we are discussing afterwards. So this is a single busbar arrangement. Now if this single busbar has a bus section, then we call it a single busbar with a bus section arrangement. In that case, it is slightly different. So in this single busbar arrangement, we can take all the feeder like this way. All the feeder will be connected in this way, one after another, and it is going to the load. Suppose this is going to a generator. Suppose this feeder is going to a generator. This feeder is going to a transformer. Suppose there is another feeder is going to some other distance switchgear. It is going maybe another switchgear. So this way all these are connected to this. Now if the problem with the switchgear, if there is some problem with this busbar, then I have to shut down all these loads. I cannot maintain any of the loads. All the generators and the transformer, everything will be out, and the total switchgear will be dead. So the total plant will be shut down. So to avoid this thing, we can do slightly different way. We can put a bus section over here. We can put another breaker over here, and then we can draw another section. So this, and then we can put the feeder here as well. We can put another feeder, all the feeder over here. Here also it is a single busbar arrangement, but with a bus section arrangement. We call it bus section breaker, or bus coupler. Sometimes we call it bus coupler. So if the bus coupler is open, means if it is open like this, then what will happen? Then it will act as a two busbar. But when this bus coupler is closed, that means it is a single busbar. So in that case, it will act like a previous one. But I have a provision, I have a privilege. If I open this bus coupler, then I can run two parts. If any problem with this part, I can open the bus coupler and I will take a shutdown of this part, and then the other part will be running. So this is the arrangement we can make it. This is we call a single bus arrangement with a bus coupler or without bus coupler. But when you go to the dual bus, in that case it will be different. In that case, instead of single bus, it will be two bus bar arrangement. This is the one bus bar, this is suppose bus 1, and this is another bus bar, bus 2. Now, in this bus bar arrangement, and these two bus bar is interconnected to each other by a bus coupler. Suppose it is a drawout circuit switch gear, so there is a drawout one breaker. These two are connected by the bus coupler. If this bus coupler is open, these two are different bus bar. But when the bus coupler is closed, it will be more or less like this. But here advantage is we do not connect this way. Here from each bus bar we put the suppose this is one bus bar and then this is another bus bar. So what we will do over here, suppose this is one breaker, this is one breaker. Sometimes instead of two breakers, what we can do, we can connect these two bus bar together, and then we can take this breaker. Suppose this is a bus bar connected over here, bus bar connected over here, we have a drought. So like this. Here advantage is we can connect this bus breakers either in this bus bar or in this bus bar. Any of the bus bar I can connect the breaker. This breaker is even connected with both this, and if this bus coupler is open, then it can run from one section, then the other section will be different. But if we want to run it independently from here, then in that case what we can do, we can put another iso breaker over here, the second breaker, and then we connect this together, and then we take the load over here. Advantage is here, if any of the breaker problem, the other feeder will be supplying power. Means I have a dual breaker for each feeder. We call it a double bus bar, double breaker arrangement. In this case, here is a, if one of the if we do not put the two breaker, in this case, if this breaker has a problem, then I don't have any alternative arrangement. But here the arrangement is, if this breaker has a problem, I can get power from the second breaker. I can put up this breaker, and I can take power from the second switch gear. So this is the advantage of the dual bus bar arrangement, and this dual bus bar two breaker arrangement. This is the drawout. This drawout means, why we need the drawout arrangement? This breaker drawout means it has a three position. Each position we call it service position. One is a service position or connected position. This is one called service or connected. Second position we call it a test position, and third position we call disconnected or isolated position. Disconnected or isolated position. These are the three positions of a breaker. This drawout means this breaker, when it is inside a tunnel, I can take out this breaker portion over a rail, and it has a three position. In service this is one position, and there is a tag on that. When the breaker will come in this position, it will give indication. Then this is the test position, this is the disconnected position. What is the feature of this? In the service position, as I said, this circuit breaker, this is the main switching device. This circuit breaker, if you see in the circuit how it is connected, this is a bus bar. From the bus bar it is connected to the breaker, and from the breaker it is going to the field through a cable. So this circuit breaker handling the main power, so it has a power circuit. This circuit breaker, if you look inside the circuit breaker, it has a two circuit. One is a power circuit, and the main power is flowing. This is a one power circuit. Second part of the circuit breaker, this circuit breaker inside various mechanism is there. All those mechanism needs a power supply to operate. That power supply we call the control supply. So it has another control supply, control electrical supply is there. So if you see any of the switch here, any of the breaker, this breaker has a two circuit. One is a power circuit, another is a control circuit. Now when the breaker is in service position, means both the circuit is on, power circuit is on, control circuit is on, means this particular supply is going to the remote location. But if the breaker is in test position, at that position the power supply is out, power supply is disconnected, means breaker has been taken out, power part is disconnected, only control supply is on. So this is why it's called test position, because during that time we can only do the testing of the breaker, but we cannot take power from the breaker because power supply is off. And third position, disconnected position, means in this position both this power supply and control supply is totally isolated. When we take the disconnected position, suppose there is a transformer over here, we need to maintain the transformer. In that case we take this breaker in the disconnected position and we put a lock, and so that nobody can open this lock and close this breaker. So these are the requirement of the disconnected position. So these are the three position, and this three position with the drawout arrangement, we can take out the breaker in this three position one after another if we need. So this is the arrangement. So now this is a further drawout type switchgear. Now if the switchgear is not drawout type, if the switchgear is a fixed type, in that case this drawout feature we cannot get. We cannot get this three position. In that case, how we will disconnect the power supply, or how we disconnect the both control and power supply? For that, we have a alternative arrangement. We need another power device to obtain that features. So that is we call a fixed type switch here, because here the components cannot, main power component cannot be moved out or move in. All the components are permanently fixed. So what will do in that case? In that case, I am drawing for a single busbar arrangement. Suppose this is a single busbar fixed type switch gear. This switch gear mainly in the low voltage, medium voltage. In case of medium voltage up to 11 kV, 3.3 kV, 6.6 kV, or 11 kV, we can get the drawout. But if the switch gear where it is installed, there is no space, it is a small area. In that case, drawout type switch gear we cannot install, because drawout type switch gear it needs a big space. Suppose a 6.6 kV switchgear is installed inside a room. For one panel, its dimension is about 1.2 meter and depth is approximately 2 meter. So this, suppose one panel, so if I have a 5 panel, it will be extended like this. This amount of area is required. To avoid this big area, if there is a space constraint is there, in that case we go for the GIS switchgear. What is the GIS switchgear? It is a gas insulated switchgear. All the busbar and the power component are enclosed inside a SF6 gas pressure. SF6 gas is enclosed inside a container, inside a enclosure, and that is a pressurized and sealed. From there gas cannot escape. There is a monitoring arrangement for the gas pressure, like our normal cylinder gas pressure. There is a pressure monitoring arrangement, and within that gas environment all these power components are located, and those components are permanently fixed. That is we call GIS switchgear. So the GIS switchgear advantage is, as it is a dielectric state around the power component is very high, because it is SF6 gas, the inside space is very less. So we about 1/3 of space we can install the same switchgear, but as the component are fixed, these drawout features we do not get. To get the drawout feature, what we do? So in case of, suppose this is a 3.3 kV switchgear, generally we do not shoot. If we, in the case of 3.3 kV switchgear, if we need this disconnected features or the test features, what we do? From the switchgear we put a isolator, and then we put the circuit breaker, and then it is going to the circuit. So what we do over here? Suppose we want to disconnect the power supply, means we want to put the breaker in the test position. What we will do? We will open this isolator. So it is disconnected for the power supply, like a disconnector. So it is like a test position. What has happened? Power supply is off. So we are disconnecting this disconnector. It is called, this is a disconnector symbol. So the power supply is disconnected, then the breaker has only control supply. So we can do the testing. But and it is also in this position, it is we call it isolated position because it is totally isolated. We can lock in this position. So to incorporate this test and isolated position condition, we have to incorporate another device over here. This device we call a isolator, and with the isolator we put another position over here. This isolated a three position. One position is disconnected position, off position you can say. This is a one position, and then there is another position for arcing. If the blade will put over here, then the circuit will be arced, so you cannot do anything on this. So sometimes we need the feeder to be arced, so we use the arcing position. So we use another device which is called disconnector cum arc switch to obtain the test position and disconnected position. So this is the case of fixed type switch here or GIS switch here. We need these arrangements. So in case of single field busbar arrangement, it will be like this. Each feeder has a 1-1 isolator, and the isolator has the arc position, and it is going to the, suppose it could be generator, it could be a remote feeder like that. But when we now if we go for the single busbar with a bus section arrangement, suppose this is a bus section breaker, then here also the same thing will be here. This is the isolator with a arc switch, and there will be disconnector over here. Breaker will be here. Similarly, this will proceed. Now, in case of dual arrangement, dual busbar arrangement, what will be the how it will be layout? Will be the single line looks like. In case of double busbar arrangement, suppose this is a dual busbar. In this dual busbar, feeder can be single breaker or dual breaker. How will make that? Suppose this is one isolator, and this breaker has this busbar has another isolator. These two isolators will be shorting, and then we put a breaker over here. So this breaker will be acting as a common breaker. If we close this isolator, power supply will be coming from the busbar 1. Suppose this is busbar 1, this is busbar 2. And these two busbar are connected by a circuit breaker. It has the isolator over here, it has the isolator over here. Both sides it has the isolator. Okay. So if this isolator is open, in that case what will happen? It will be acting as a two independent busbar. Sometimes with this isolator, there is the arcing provision is also over here. The busbar can be directly arced if we require. Now, in case of suppose I have a two feeding here. Now suppose this is running from here. Now for any unfortunate reason there is a problem with the busbar, or we need to maintain this busbar, then we take the busbar shutdown. In that case, what will happen? We will open the isolator and we will close this isolator. So this busbar is not available. It is dead busbar and grounded. So we will get a power from here. So these are the advantages we will get when we make this type of arrangement. But it is a single breaker. Now sometimes some emergency power plant, emergency utility by a station where power supply is very critical. Suppose this breaker has a problem. There is some problem with this breaker. Immediately till this breaker is not getting repaired, you will not get power from here. Suppose this feeder is going to the airport. So in that case, if it is going to the airport power supply is very emergency air supply. So we cannot, even in 1 minute, we cannot put off this supply. So what we will do here, instead of single breaker, we will go a dual arrangement. What is that arrangement? So instead of connecting over here, what we do in case of dual breaker arrangement, same double busbar dual breaker arrangement, we will put one isolator over here, then we will put a breaker here. And then we will put another isolator over here, there is another breaker, and then it will go to the feeder. So this is a arrangement. Here you see each feeder has a one breaker, this breaker, this breaker. When this isolator is off, power supply will go from here. If for any reason this busbar has some problem, we will open this isolator, we will close this isolator, power will go there. Suppose this breaker has a problem, then immediately we will open this, we will disconnect this breaker, we will connect this one, power will flow. So any of the equipment failure will not disturb my power supply. This is called dual busbar dual breaker arrangement. It is quite expensive because here two breaker has to be installed. So it will be more space will be required, more cost is there, but more flexibility I will get it. So in a brief, when we are going to control schematic discussion, we can see from here that whenever we put any breaker on the upstream on the bus side, feeding side, there is another power device which is called disconnector. This disconnector, depending on the disconnector connection, the power supply may be available, not available. Before closing the breaker, if I put this, suppose from the circuit it is clear. If we want to, this breaker has a power circuit. The power circuit, power is coming from the busbar, there is a contact inside. There is a contact. there is a contact. If this contact make on, then only power will flow. So when we contact make on, then we call breaker is closing. So before closing the breaker, I have to understand to confirm that this isolator is on. If this isolator is open and if I close the breaker, power will not go. So again, if the isolator is off and the breaker is closed, nothing will go there. So before closing the breaker, I have to check this interlock. Suppose another point is there, suppose there is a arc switch is also over here. If this breaker, this isolator is in arc position and if I close the breaker, then what will happen? The breaker will be get arc. So that is also I have to check the breaker is not in the arc position. If we do not allow the breaker to be closed on arc position, then this interlock also I need to check in the control schematics. So in case of control schematics understanding, this isolator is an important part. That's why we discuss the layout portion. So from the layout it is clear that each breaker has one isolator, arc switch, and that isolator status to close the breaker is required to be monitored before closing the breaker. Now this is for the medium voltage switchgear, there is only one isolator. But when we go to the high voltage or extra high voltage switchgear means 66 kV, 132 kV, 420 kV, 400 kV or 565 kV means 600 kV or above up to 800 kV. If we go any of the extra high voltage up to this point we call it high voltage, this point we call it extra high voltage. Sometimes 220 kV we call it high voltage and this is we call extra high voltage EHV. When they go to the EHV operation, in that case this busbar arrangement again, suppose this is a dual busbar arrangement, this is a bus 1, bus 2. Here also we have an isolator over here, here we have an isolator over here. Now we have a circuit breaker over here, but here on the load side also we put another isolator, because for the extra high voltage or high voltage system, power can feed from both ways. This way power can feed, this way power can feed. So this way we have so far the medium voltage power feeding from the busbar one direction, but extra high voltage or high voltage system power can feed from this side, from the remote substation also power can come this way. So if the power comes this way, this side also we need a, before closing the breaker, we need one isolator to understand the breaker. Before closing the breaker, we need to understand whether the remote side power is coming from this side or not. So that's why on the load side also in the high voltage or extra high voltage we need another isolator. That means in case of circuit breaker there are two isolators, one isolator on the bus side, another isolator on the load side or on the outgoing side. So here also the same arrangement we can have a dual busbar arrangement. Suppose in this case single breaker, two isolator and a single breaker and there is an isolator. It could be also a dual busbar with a dual breaker arrangement. We could have another breaker over here and then isolator and then we can connect over here. So I can take the power through this path or we can take the power from this path. This is the dual busbar, dual breaker arrangement. Or dual busbar, it could be happen also like that. It could be one isolator over here, one isolator over here, then it is a connected, then this is a breaker, and then there is another isolator. This arrangement also there. It is a dual busbar single breaker arrangement. Sometimes we call also 1.5 breaker scheme. There is only scheme called 2.5 breaker, 1.5 breaker scheme. In that case, instead of single or dual breaker, we can take 1.5 breaker for each circuit. Actually, there it is a the arrangement there are two busbar. This is one busbar, this is another busbar. So from the busbar there is an isolator, then there is a breaker, and then it is extra. Generally, this 1.5 breaker arrangement, 1.5 breaker arrangement we use for the extra high voltage system to reduce the breaker requirement. Then feeder will go out from here. This is the feeder going. Then again another isolator, one breaker, one isolator, then another feeder is going from here. And then we have a breaker and then isolator this. So normally this breaker is off. This circuit breaker is off and power is feeding from this way. And another power is going, there is isolator over here. The power is going from here. When any, suppose this breaker for any reason, any problem or this isolator has some problem, then we open this isolator and this breaker is off. We make this breaker is on. So the power will go from here one circuit, then we close the isolator, power will go from this circuit. Here two circuit we are using, but we are using three breaker. This is the three breaker we are using for the two circuit. As three breakers are using for two circuit, for each circuit that is 3 divided by 2, that is 1.5 breaker. That's why it is called 1.5 breaker scheme. Sometimes we use this type of arrangement also. These are the various type of arrangement we use for the circuit breakers or the switchgear. Now with this, in a brief, you can say another way. Now when we are going to the control schematics of the circuit breaker, we have to keep in mind each circuit breaker has a one or two isolator. In the case of medium voltage, only one disconnector, but in the case of extra high voltage, there are two disconnectors. This two disconnector condition we have to monitor during closing the circuit breaker or opening the circuit breaker, or whatever the work we want to do with the circuit breaker. Disconnector status, whether it is closed, it is open, or it is going to the earth position, that to be monitored. And that monitoring is the integral part of the control schematic. That is the, in a brief, from this part we can discuss, we can keep this thing in mind. So this is the first part. The second part of this today's discussion will be to discuss the control schematics. When we look into the control schematics of a circuit breaker, we will see that this circuit breaker control schematic consisting of various parts. Now if we look in details of these various parts, any switchgear, medium voltage or high voltage or extra high voltage switchgear, or even in the low voltage switchgear below 1 kV, all the switchgear control schematics has mainly 8 parts are there, is control schematics. Now these 8 parts, what are those 8 parts? The first part of the any control schematic is the closing control schematics. Circuit breaker, you can say circuit breaker closing schematics or closing scheme. This is the first part of the circuit breaker. Any circuit breaker, if you go, the first part of the circuit breaker is a circuit breaker closing schematics or closing scheme. Second part, this is a control, any switchgear control schematics. When we want to discuss control schematics, any control schematics of a switchgear, if we look minutely look into the switchgear control schematics, we can see the control schematics has 8 different parts. First part is the circuit breaker control scheme, called control closing schematics. Second part is a circuit breaker, same thing, circuit breaker off or tripping scheme. Now here we have to mention what is the difference between off or tripping scheme. Off scheme means any of the switch. Suppose in your house, the switch you can switch on or manually. That is what intentionally you are doing on or off. In the case of circuit breaker also, due to your operational requirement, you can open the circuit breaker manually or with your intention, when you intend to open it. That is knowingly you are doing it. In addition to this, if there is any abnormal condition persists or abnormal condition takes place in the circuit which is supplying power, in that case the circuit breaker automatically get open. So when it gets, due to abnormal condition of the circuit, if the circuit breaker gets open, then we do not say it is off, we call it trip. When the circuit breaker is getting open on tripping, means there is abnormal condition of the circuit breaker or the circuits or any part of the circuit. Due to it, circuit breaker has automatically opened. So in that case, we do not close the circuit breaker immediately without investigating the reason why the breaker has opened. But if I open the breaker manually intentionally, then I know I have opened the breaker. In that case, immediately I can close the breaker. But in case of when the breaker is getting tripped, means it has due to some fault or due to some abnormal condition of the circuit, it has happened. So we will not close the breaker. So these are two terms we are using. Though in both the cases, circuit breaker will be, power circuit will be open. The circuit breaker contact, this contact will get open inside the breaker. So power cannot flow. But both this could happen manually, it could happen automatically. When it happens automatically, we call it a fault trip, or due to fault tripping has taken place. So we have looked into in that way. So this is the second part of control schematics. Third part of the control schematics is this breaker and the isolator along with any other various devices are in the circuit breaker, in the switchgear for each feeder. When you look into all this alarm, all this indication, this status of the various power component, this condition of the various abnormal condition or normal condition, we need to monitor. This monitoring we can do by indication lamps, by indicating lamp, or it can be monitored by the alarm. So there is an alarm or indication circuits. Alarm oblique indication scheme. We can say this is another part of the control schematic, alarm or indication scheme. And this alarm and indication scheme, it could be locally in the switchgear, or it may be some remote control room. It could be remote area. This indication can be taken as per the requirement. It could be in the process area where the process is taking place. So this is one scheme is required for the alarm and indication. Number 4, in this control schematics, we are using the various devices like circuit breaker. We are using isolators. We will be using various protection devices. We will be using other mechanical devices. All these devices has some auxiliary contacts. If those auxiliary contacts are not adequate to complete the scheme, suppose some contacts are short for to give the alarm indication, or some contacts are short for complete the control schematics, we put some small auxiliary relays to multiply those contacts. So that auxiliary relay in a switch gear, there is lot of multiple auxiliary relays are there. So that multiple auxiliary relays also need some. It can be also displayed in the proper way to understand how the auxiliary contact of the relays are used in the various parts. So that is also one part of the switchgear control schematics, that is called auxiliary relay control schematics. Auxiliary relay control schematics. Relay control schematics or control scheme. This is the 4th. 5th part, as we said already, in this circuit breaker for each feeder there is a protection relay. There is one protection relay or two protection relay or multiple protection relay depending on the type of feeder. To the DJI, due to the numerical relay development, now only one relay, in most of the cases, one relay can serve all the functions, or maximum maybe in case of generators or complicated device, maybe 2 relays will be required. One is a common protection, another is a differential protection. So this relay, it has a protection scheme, it has a various auxiliary contact. This relay can take various input, it can give various output. Input, it can take digital status input, it can take analog input, CDBT supply, it can give various digital output, analog output, digital output. All this part can be demonstrated in a protection relay control scheme. So there will be a protection relay, it is not the auxiliary relay, it is the main protection relay control part or scheme, protection relay control scheme. This part contains, this scheme contains input output device, input signal, output signal, and relay internal various auxiliary contacts, and how many auxiliary contacts, where it is going, how you are using, and how the relay is getting monitored. All these features under this protection relay control scheme. Number 6, we have another part is there. In this circuit breaker and the isolator, the circuit breaker has various auxiliary contacts, and all these auxiliary contacts, it has a motor closing mechanism, it has a control supply. All these things we need to demonstrate in a separate scheme. That is we call circuit breaker own scheme. Circuit breaker own scheme. That is another part of the control schematics of the switchgear. Then number 7 is this switchgear. Suppose this is a transformer feeder switchgear. This switchgear panel, it is connected to the transformer now, and then this various alarm indication, CTPT, all these things, maybe it is located on the transformer, from where it is coming to the switchgear. Then from the transformer, main power cable is coming to the switchgear. Then from the switchgear, various alarm indication cables are going to the DCS, process area, or other area. All this cabling has to be made. That means this switchgear panel has an interface with external world, means outside the switchgear there are various field equipment. Those field equipment are interlock or interconnected with the switchgear. So there is an interface between the switchgear and the various field equipment. That interface scheme also we need to demonstrate under this interface scheme with various field devices, field equipment, that also we have to demonstrate under this control schematics. Last part is that this circuit breaker various control parts protection relay, closing part, trimming part, alarm indication part, interface scheme part, all this part need auxiliary power supply. As I said before, circuit breaker or switchgear has a two supply. One is the main power supply that could be 3.3 kV, 6.6 kV like this. In addition to this, there is a control supply which is normally DC supply. We use either 48 volt DC or 125 volt DC or 220 volt DC depending on the availability. So this control supply, it should be very reliable and under any condition it should not get off. So there is a scheme to get this specific type of power supply. So sometimes it is instead of DC, it could be UPS AC supply also there. So that AC or DC supply, whatever you give as a control supply, that control supply reliability must be ensured through a proper changeover scheme. So normally there are two supply we take with changeover scheme. One supply is coming. So if one supply off, other supply will automatically be maintained. So that control supply will never fail. So that is also one of the scheme, control supply scheme. In addition to this circuit breaker switchgear panel, it has some indicator, it has some lamp inside, light for looking or viewing inside the switchgear. Sometimes the switchgear it has some plug socket for connecting the laptop or some other auxiliary devices. Inside there is a heater due to condensation. To avoid the condensation, there will be heater that also need auxiliary. Normally that is AC power supply, auxiliary 120 volt or 220 volt AC power supply. That also inside the switchgear. So this control schematics of this auxiliary power supply, either control supply or auxiliary power supply, is also another part of the control schematics. Number 8 is a control supply, main control supply or auxiliary power supply, changeover process, changeover logic, and its distribution is another part of the control schematics. So these are the 8 parts of any switchgear panel control schematics. So this part we need to discuss to understand the complete control schematics of the switchgear. So now this is the first session we are doing. For session 2 and onward, we will be discussing one by one these various parts. So each part maybe will be one session. So there will be another maybe 8 session to complete this control schematics. So with this today we are closing our discussion. In the next session, means session 2, we will be discussing the circuit breaker control scheme. And with that I am closing this session today. Thank you very much. And if it is helpful to any one of you, it will be my great pleasure. Thank you very much indeed.